Hello everyone, welcome back to my channel. Today we are going to be talking about backtracking, which happens to be the last pattern we have on this list. So, backtracking. This pattern is typically used for questions that involve some form of exhaustive search. Right. So if you see questions that involve some form of exhaustive search, or exhaustively searching all the possible, like all possibilities. So this involves questions they have to do with, some path finding. Imagine like trying to find a path in a maze, solving puzzles whereby you make one decision, you recursively call the function to solve that puzzle, and then you undo that decision. So usually for questions that are amenable to backtracking, we tend to implement it using recursion. However, after performing this recursion, we have a particular action we perform before the recursion and a particular action we perform after the recursion. Yeah, so the way it goes is, say that we perform an action, we have a recursive function, we perform an action, we call the recursive function here, and then we undo the action. So you see, this step of performing an action changes the state of the object or of our results. Then we recursively call the initial function. Let's say we call the function backtrack. We recursively call this initial function again, recursive backtrack. Then we undo the action that we perform. You see, this step of undoing this action is what we call backtracking. Yeah, so let's just take a quick example of the kind of questions whereby this could be amenable to. Yeah, so say for example, we have a set of numbers. We have, you know, there's a question that has to do with some a particular IP address format, and then you need to divide the numbers in such a way that it makes sense. It makes sense as an IP address range. Yeah, so for this kind of question now, you imagine that we need to try all possibilities, of dividing these numbers into four different sections. Yeah, so the IP address range is, I mean, the IPv4 range. So it's sort of something like this. So you have one set, a dot, another dot, and then you have one final dot. Yeah, so this range here typically you go from all the way from 0 to, not really sure now, I think it's 198. Can't really remember, but it goes all the way. So it can either be 0 0 0 0, yeah, all the way. No, actually it's 2 to 5. So it can be either 0 0 0 or all the way to, this can be 2 to 5 and 2 to 5, like that. Yeah. So now you have this number, and you need to sort of find a way to place different dots here so that it makes sense, right? So like maybe find all the possibilities, all the various IP ranges that can be formed using this. So imagine you can have this, you can have, that's one, can be another one here, then can be another one here. This will make sense. Another one is we decide to put it in front of 12 and then put another one here, and then have like 5 here, and then have this one as 11. Yeah, but you can imagine that if we had zeros somewhere here, say we have like 1 2 0 4 5 1 1. Yeah, so like we will not want to have this, for example. This, I mean, we will not want to have, because this will not be a valid range. So it's rather it would just be 12.4. Yeah, so having those that precede here, this one will not work. Yeah, so these are the kind of questions that backtracking can work for. Yeah, so what we will do is, imagine that we have like a string that actually holds the current state of our backtracking function. So say that we have a string that holds the current state. So within this function, the action there will be to, take the next character that we need to use. So say for example, we are at an empty string, take the first character will be 1. Yeah, so we form 1. Then we'll now call recursive backtrack function using this one, and then going on to the next state. Then we enter the next state and we say, okay, so we had to. That's the next thing. The next action could be, okay, you know what, add dots. Okay, rather than add three, add dots. But once we are done with the recursive backtrack function, what happens is the undo step removes the character that was last added. So in this step, let's say dot was what was added. This undo step will remove that dot from the current string, the string that is passed here. It will be like maybe string to remove, last character or something like that. Yeah, if it was two that was added, it will remove the two. Yeah, so that's the idea of backtracking. So we have an action that is performed within the function. We recursively call the backtrack function. Then we undo the action that we performed. Yeah, so at some point, maybe when we're done with all the exploration, say for example in this case, we've gotten to the end of the string, we've used all the characters left in the string. Then we'll now say, okay, so is this a valid state? If this is a valid state, yeah, so if this is a valid state, then we could have like a list of strings, that holds all the solutions. So we add this string, yeah, this current state that we add it to the solution saying that this is a valid state. If it's not a valid state, and then regardless of whether it's a valid state or not, since we've gotten to the end, we just return. Yeah, so once we return, we undo the last character that was added, and then we continue to backtrack. Yeah, so that is the idea of behind this backtracking. It's so, like I said, it's an exhaustive search process. Usually, even problems that are amenable to dynamic programming, yeah, we can use backtracking for it. The only issue is that for those kind of problems, usually is when we want to enumerate all the different possibilities. We don't just care about if there's a solution or not. Yeah, we want to enumerate all those possibilities. Yeah, so that's where backtracking comes up. The other possibility is this question also, you can see it uses some form of recursion, and it looks like a depth first search kind of question, and that is actually true. Yeah, so for questions like maze finding, exploration of a maze, you can actually use backtracking for it. It all comes down to your understanding and the implementation that you choose to go ahead with. There are a couple of questions actually that tend to use this pattern. Some of them I've mentioned. Other ones are this popular question called the n queens. I think it's categorized as hard, yeah. And the reason why it's categorized as hard is because there's a lot of implementation going on. But it's basically just backtracking. Yeah, you need to perform an action. You need to check whether the state that you are in is valid. If it's valid, you keep track of that state. Then you recursively, so that's after you've recursively called that state. Then when you are done from that recursion, you undo that state. And that's basically it. So regarding the time complexity, so the time complexity actually depends on the kind of question that you have. Yeah, but you can imagine that for all the different states that are possible, depending on the inputs, so see in this case now, we have an input length of the size of all of this. So let's say that we say the length of all of you, we will call this backtracking function at least for the length of all of this. Then within this backtracking function, the what we can perform in this action, yeah, now determines how many times this will break. Yeah, so in this case now, we can say we're going to take one character. That's one. We can say that we're going to take two characters, and at the same time we can say that we're going to use a dot. So if we have like three different actions that we can perform, or if it's like a number of actions that we don't know, say we can loop through the entire list all over again, then that will be like times n. And at the end of the day, that will be n squared. Yeah, so the time complexity of backtracking problems are not entirely straightforward. You cannot just create like a general time complexity for it. Yeah, you need to analyze what exactly you are doing in that question and the steps or the action that you're performing. But generally, the idea is perform an action, recursively call the backtrack, and then you undo the action that you just performed. Yeah, so thank you guys for joining me in this session where we've discussed the final algorithm pattern on this list, the backtracking pattern. See you guys once again, where I intend to now start discussing each of the questions or some sample questions about all of these patterns in some new set of videos. Might be taking a little bit of break, yeah, but just know that I'm cooking something good, right? Something that we will all benefit from. Yeah, so keep your fingers crossed and see you guys in another video where we'll be discussing the detailed solution to some of these questions that involves the use of these patterns. See you guys once again. Bye.